So today we're taking a first look at the TETRA R, the first console-style case from Thorzone. I've been very excited to try this case ever since it was announced late last year, and I'm lucky enough to be one of the first to get a chance to build in it. So I'm going to put it to the test with my RTX 5090 Founders Edition to see just how well this form factor can handle the double flow-through design. I'm also going to be comparing it directly to the Thorzone NANOQ S, which has received several quality of life upgrades as part of the Batch 3 release. So let's start by taking a first look at the TETRA. Just like with the NANOQ, the TETRA will be available in two sizes. The R, which I have here today, coming up at 12.5 liters, and the S at just 9 liters of volume. The TETRA is using a console-style layout, with each component more or less able to use the entire width of the case. Its biggest advantage over the NANOQ S lies in its ability to fit absolute chunkers of GPUs without obstructing airflow on either side. Design-wise, I find it very striking. The extruded aluminum shell I think looks really good in this form factor. There's just something very industrial about it, especially in this silver variant. Let's take a look at the internal design of the TETRA. The very first thing we notice is that the interior is dominated by these super long steel standoffs. You'd be forgiven to not have noticed this in the renders, I certainly haven't, but in the TETRA, the motherboard actually gets inserted face down onto these long standoffs. Thorzone tells me this was done in order to maximize CPU clearance. It's certainly unusual, but I am up for the challenge. We also have a super short riser that does a sort of 90-degree bend towards the motherboard PCIe slot. And then we have 3 more standoffs onto which we can add one stem fan to help with exhaust. One thing missing here, however, is a way to attach additional fans when using a 2-slot GPU like the 5090 Founders Edition I'll be using. But things are a bit more complicated here, and we'll get to that a bit later. On that note, let's start assembling everything, starting with the GPU. There's no anti-sag bracket here, but the way in which the GPU mount is designed is excellent. We have a metal piece that locks the GPU I/O bracket in place, eliminating all possible movement. This results in a mount that feels super secure, and I'm very impressed with how solidly the GPU is held in place. Next, I added the PSU to get an idea of how everything fits together, but it would actually be better to leave this for later. I'm running my trusty Asus B650EI with the Ryzen 9800 X3D CPU and 64 GB of Corsair RAM. Cooling is handled by the Thermalright AXP120X67 with the fan swapped to the Silverstone AirSlimmer 120. This setup pretty much maxes out the available clearance inside the TETRA R, and we'll have a look at CPU performance a bit later on in the video. Now for the fun part, motherboard installation. And this is where I ran into a bit of a roadblock. The motherboard simply refused to cooperate. Something was keeping the backplate from going into the rear panel cutout. I even tried a different motherboard with the same result. After talking with Thorzone, we realized it was a small detail in my pre-production unit that interfered with the motherboard backplate. Fortunately, this has already been addressed for the production run, so it's really just an issue with my review sample. So in order to continue, I removed the integrated backplate on my B650EI motherboard. It was only held on by 2 screws, so there was nothing destructive done here. And sure enough, I was now able to get the motherboard installed. The last step here is to insert the riser into the PCIe slot. With the motherboard in, all that's left is basically just a lot of cable management. I removed the PSU to make it easier to route cables, especially the ones for the front panel USB Type-C, the power switch, and the motherboard 24-pin. With those in, I added the PSU back and then did a lot more cable management. I used one of my sets of custom cables for the Corsair SF1000, but the lengths I used here were not customized for the TETRA, with the motherboard 24-pin cable being the most difficult one to route as it was a bit too long. It's super important to make sure that all the PSU cables are zip-tied and held away from the fan blades, as there's not a lot of room here. I added a Noctua slim fan here set to exhaust. This is actually our only case fan, and I'm not convinced it will contribute much to the cooling of the TETRA R, but I suppose it's better than having no fan at all. The end result does look pretty great, but it does feel like there's a bit of unused volume here, especially in that top GPU compartment. If anything, the 2-slot 5090 Founders Edition feels a bit undersized here in the TETRA R. Overall, I think building in the TETRA is quite enjoyable. It's definitely not too difficult, other than the unusual motherboard mounting, for which you will need to be a bit more careful. Right, so with everything assembled, it's time to slide the shell onto the core. As always with Thorzone cases, be prepared for some metal on metal scraping sounds. The assembled case does look stunning though, and the stainless steel feet are a very nice touch. The case is also surprisingly stable. Even with a high center of gravity, I wouldn't be too worried about it toppling over. So let's put the TETRA R to the test. Before we take a look at temperatures, let's actually talk a bit about fan noise. Right away, what surprised me about the TETRA, at least with my particular setup, is the total absence of any fan turbulence. On the CPU side, there's still a nice gap between the fan and the shell, and the intake fans of the 5090 are actually facing towards the inside of the case with the exhaust side facing out. Take a listen to what the case sounds like with the fans running fixed speeds, aiming for an overall level of 40 decibels. In order to test cooling performance, I'm using Star Wars Outlaws as my soak test due to its relatively high GPU power draw, averaging just above 400 watts. Do keep in mind that, as with all my testing, the 5090 Founders Edition is running an undervolt profile with a memory overclock of 3000 MHz. To me, this is simply a no-brainer for getting essentially stock performance with a significant reduction in power draw. And I do have a video on undervolting the 5090 FE, which I'll have linked in the video description. So let's see how temperatures look after 20 minutes of running the soak test. Temperatures get quite toasty on the GPU with a max of 82.8 degrees. This is quite high for running the fans at 45% and an ambient temperature of 23.5 degrees. 50 series cards no longer have a hotspot sensor, but judging by memory temperatures reaching 98 degrees, things simply aren't looking very good here. This is particularly disappointing to me, as I was a firm believer that a console-style case would really benefit the double flow-through design on the new 50 series cards. CPU temperatures, on the other hand, are a different story, generally settling at around 60 degrees after 20 minutes of running the soak test, which is excellent. Let's take a closer look at CPU cooling. A test I like to do is the initial shader compilation step in God of War Ragnarok. The 9800 X3D will tend to boost up to about 145 watts in all core scenarios, provided there's enough thermal headroom. If we take a look at this log recorded during shader compilation, we see that temperatures quickly rise up to the thermal limit, and the cooler struggles managing more than about 130 watts. It's a good result, but there's still a slight compromise made here for all core workloads. I also ran a 10-minute soak test using Cinebench. We get an initial peak up to 145 watts, but temperatures quickly reach the thermal limit, and after that we settle slightly below 130 watts on average. With the fan running at its maximum speed on the CPU, we get a headroom of about 135 watts. So CPU temperatures are fine, but what could we do to improve GPU temperatures? What we could do in theory is add a 20mm standoff mod on the riser, which would then shift the GPU inwards into the case, and then we could design some sort of side bracket that will allow us to add two fans to help with exhaust, essentially giving us a push-pull setup. But even so, we would only be able to use slim fans, and it may make slotting in the riser very difficult. And at least for this video, I'll not be using any custom mods and will be keeping everything stock. Instead, I decided to compare the TETRA R directly to the NANOQ S. The cases are actually quite close together in volume, with the TETRA being 1.5 liters larger. I think it would be interesting to see if a sandwich-style setup is actually better for a GPU like the 5090 FE. The NANOQ S I have here is a pre-production batch 3 sample, which now comes with a PCIe Gen 5 riser just like the TETRA, but more importantly, it comes by default with a 20mm GPU offset kit. This lets us get a nice gap for the flow-through design on the 5090 Founders Edition and should considerably help with cooling. I use the same parts in both builds, but of course one of the main differences is using a different CPU cooler. So I'm back to using my trusty Thermalright AXP90 X47 full copper, kitted with offset brackets and a Noctua fan swap in order to get every last drop of cooling performance. Unlike the TETRA, we can fit up to 3 case fans in the NANOQ. One slim fan attached to the front panel, for which I used the Silverstone Air Slimmer 120, and for the main exhaust fans, I used a pair of the new Noctua NF812 X25 G2s for their excellent sound profile. So the first thing that stands out about the setup in the NANOQ S is how all the available volume is maximized and put to use. It's also just a bit easier to handle, and overall, the internals make it feel like the more refined case, which objectively it is, as it's been continuously improved with each new batch. As with the TETRA, I first wanted to check for any fan turbulence issues. Unfortunately, because the 5090 FE is sitting so close to the shell, we're getting quite bad turbulence from the fans. Take a listen. As I learned myself from experimenting with custom panels for the Form T1, bigger holes are actually worse when it comes to managing fan turbulence. On the other hand, the Noctua NF812X25 G2s sound great, even at 100% fan speed. They sit quite far away from anything that could introduce turbulence, and this is clearly reflected in their sound. Let's see how the NANOQ S build performs in terms of temperatures though. Running the same Star Wars Outlaws soak test, we get a maximum GPU core temperature of 75 degrees. That's almost 8 degrees cooler compared to the result in the TETRA, at the same fan speeds and the same ambient temperature. We get an 8 degree temperature drop on the GPU memory as well, consistent with the drop in core temps. That's absolutely a massive reduction in temperatures, and it seems clear to me that it's the exhaust fans doing the heavy lifting here, helped of course by that one slot gap introduced with the 20mm offset. On the CPU side, temperatures settle at around 65 degrees, about 5 degrees higher than what we got in the TETRA with the larger cooler. I find it perfectly acceptable and would happily make the trade for the better temperatures on the 5090. If we take a look at the Cinebench result, we see that the EXP90 X47 full copper ends at about 118 watts, that's about 10 watts less than the larger cooler managed to handle in the TETRA. And it's pretty much the same story with the fan running at its maximum fan speed. We get about 10 watts less cooling headroom. I expected a bigger gap here, but as it stands, I definitely would prefer the NANOQ S over the TETRA, at least with the 5090 Founders Edition. The awful fan turbulence could be solved by reducing the offset by about 5mm, although that would require a custom GPU bracket for the rear panel, which I may do in a future video with the NANOQ S. So let's recap. The TETRA has an excellent noise profile with the 5090 FE and the EXP120X67, but unfortunately GPU temperatures are disappointing. The big benefit of the TETRA R may be fitting larger 5080 or 5090 cards like the Asus TUF or the Gigabyte WindForce, but I'm still skeptical of cooling performance with no dedicated exhaust fans and would perhaps look towards the NANOQ R. The NANOQ S is simply the better choice to go for if you have a 5080 or 5090 Founders Edition card. The turbulence is awful, but I think it can be solved with a less aggressive offset, provided you are open to using mods. Overall, I'm really surprised with the results. I really expected a console-style case to offer an edge for GPU cooling, but it really goes to show just how important exhaust fans can be. So really, what the TETRA offers is a sleek form factor with a tiny footprint in its vertical mode, and the ability to fit those larger AIB GPUs in a relatively tiny form factor. Then there's also the TETRA S, the smaller 9-liter version, which will be coming later this year. I really like the form factor, and I think the S may be the one to go for between the two, perhaps paired with a slightly less power-hungry GPU. But that's going to be it for the time being. If you like the content and would like to support me, then using the affiliate links in the description would go a long way. Or you could consider joining my Patreon, where you can find fan control configs as well as my custom RDSS overlay. And of course, don't forget to subscribe if you haven't already. Thanks a ton for watching, and I'll see you guys in the next one real soon. Bye for now.